Hello, everybody. I'm going to be talking a little bit about Go today. In particular, I just want to give you a sense of what I'm actually going to cover today. To get started, I'm going to give a high-level overview of Go as like a language and why you might want to use it for your own personal projects, but also why we use it at Next Jump. After that, I'm going to go into a crash course where I'm going to cover the basics of Go, such as variables, packages, functions, etc. And then I'm going to give a quick overview of a Go application that I built recently using purely Go to make a web application. So you'd be able to follow it as a blueprint for your own personal projects or whatever you're working on. So to get started, I wanted to give some context of where Go fits into our overall enterprise. Like Tom was showing with the stack diagrams, Go is a part of our service layer. So we have a lot of different products, like the virtual currency, travel reservation engines, transaction processing. There's a lot of different systems that we run and maintain for millions of users at NextJump. And in particular, there's a bunch of different front ends that access all these systems, like the website, the actual corporate perks program, the mobile site, emails, internal tools, even third-party applications. All of those different front ends, the intent is that they all go through our service layer, and that is the wrapper around our database and domain model. So the database obviously is the key place where we store all it's like the true source of data for all of our systems, and then it propagates through various systems and layers of caching outside of there. The benefit of having a services layer for the most part is consistent data access. That gives us the ability to log access to sensitive data, to see like how our data is being used in case like even if there's a leakage, but also if there needs to be more resources devoted to a particular system. Having a consistent place to access all of that is really valuable. And another benefit of it is when the definition of something changes, you only need to change it in one place. So if the definition of what a platinum org is, for example, changes, if that's not defined in a service layer, we have to go through and change it every system that we've used it, like Mercury or mobile or whatever. So it's a really a strong benefit and reduces the amount of duplicate work and copying that we need to do. So before getting into too many details, I just wanted to share what Go code actually looks like. So this is the very simple hello world. At the top line, there's a package declaration. The main package is the default package for each application. Then we're importing the format package. That's responsible for writing out to the standard output. Then there's the main function, which is the entry point into this package. And then we're just saying a print line and format hello world. So overall, there's some really important characteristics to be aware of when you're talking about Go and considering using it for your own projects and what we considered when we looked at it. First of all, it's very new. So if you look at C, which might be from like the 70s or something like that, Go was created in this millennium and also very recently in this millennium, so in 2009. Another important characteristic is it is statically typed. So that means if a variable is a string, it's always going to be a string. It doesn't change types depending on the context or anything like that. It's compiled, so generally in historically compiled language means like slower for innovation because you have to compile it, then you can run it. But we've gotten a lot of benefits out of using a compiled language. Go compilation is actually really fast as well. In terms of how it looks, it's very similar to C. So if you've used any sort of C-like syntax language, it's pretty easy to pick up the syntax of Go. So I'm going to go through a bunch of the reasons why we ultimately chose to use Go, things that, as an architecture team we liked and felt like were important. The first example that I'll go through is actually the speed. Go is a very fast language. So the diagram on the right, the important thing that I'll draw your attention to are these bars here. So what this is doing, there's a comparison between Go and Ruby and Go and PHP. So this bar indicates that in this particular benchmark, Go was 10 times faster than PHP, or 30 times faster than PHP, or 100 times faster than PHP. So generally, when we're looking at common algorithms, Go is at least an order of magnitude faster than a language like PHP. So one caveat is these are not web-specific benchmarks. So just because you're using a faster language doesn't mean you'll be able to deliver a web page faster to a user. That's a whole different set of benchmarks that we'd have to get into. But on the whole, if you're doing a very similar task, Go is going to be significantly faster, and that's part of the reason that we ended up using it. Now, I talked a little bit about this, but static typing is a really important characteristic of the Go language and part of the reason why we used it. So in the example code here, we have two variables, A and B. A is a number, and B is a string. And so we assign A as the number 10 and B as a string 10, and we try to add the two of them. Now when we run this, the Go compiler won't actually compile this code because it doesn't know how to handle a situation where you're adding a number and a string. Now, if you're coming from a language like PHP, you expect this to actually work, and it might do something. But it's not clear like what it's going to do. It might turn the 10 into a number and give you 20, or it might turn the first 10 into a string and give you 10, 10. When you're working in a huge team with a lot of different styles and things, having a compiler that's more strict and catches weird behavior like this really helps you be able to dive in and understand how code is actually going to work. Because if a number if a variable is a number, it's always going to be a number. It doesn't change around. The compiler also gives us a bunch of other advantages. Like, for example, if you've looked at our PHP code base and you look at a controller, there might be hundreds of variables, and it's not clear which of them are actually ever used. The majority of cases, probably half of them aren't even used. They're just there, and everyone's too afraid to remove them because they might be used, or they might be used someday. The Go compiler doesn't allow for unused variables. If you have a variable declared and you don't use it, it won't compile. So it automatically forces us to keep cleaner code that's more readable. Additionally, it's just safer to refactor, so if you delete a variable and it is being used, it'll catch that. And it catches other simple mistakes where you're adding a number and a string. So just for a comparison, this is JavaScript, the same code. It's not easy to predict that would give you 10, 10 as opposed to 20. So that's part of the reason that, working with Go, it's more predictable. You can look at the code and understand what it's going to do. There's no surprises. That's one of the great benefits of using a language like Go. So another important reason why we use Go is the simple specification. And what I mean by that is generally there aren't like 50 ways to do the same things. In really expressive language, you can be very creative and clever and come up with an interesting and fascinating way to accomplish a problem. In Go, it's like a very simple toolkit where if you're looping, this is the way you loop, and that's pretty much it. Like, there's no while loops, there's no do while loops, there's no maps and filters and folds. Like, all that clever stuff is not in the language. So an example here, this is how you loop in Go. There are just 4 random things I came up with how you could loop in JavaScript. Having one way to do something simplifies the code. You look at someone else's code and you know what it's doing. Part of the simple specification is there are some features that are common in modern programming language that are deliberately left out from Go. An example is inheritance, overloading, generics. At first, these might not seem like important trade-offs, but as you get more familiar with the language, as you get more confident as like developers using object-oriented programming techniques, the lack of these features does cause some pain. You have to get used to like not using them and what the trade-offs are. But ordinarily, what we found is that it doesn't really matter. If you're writing good code and it's simple, you don't necessarily need all these features. There's other things that are missing, like prefix increment operator, so this ++i. You'll see this pretty commonly, but I would argue that most people don't understand the difference between prefix and postfix operators like this. And then the ternary form of if, question mark, the true value, colon, the false value. I use this a lot in PHP just because it's simple, but it's pretty poor form. It's harder to read, and people go crazy and put a ton of stuff in this if block, and it becomes like unreadable very quickly. So that's missing as well. So you'll notice that the diagram on the right here looks a lot what Tom was talking about in terms of the stack. One of the reasons that using Go is nice is it simplifies the technical stack just in the application level. So there's some interesting examples here where PHP, if you're running PHP, generally that's running on an Apache server, which is a Linux machine. So you have you need to configure Apache in order to run PHP. Java is even more complicated, where you run the Java language, which is generally run inside of application server container like JBoss or Tomcat or Glassfish or any number of those things. And then you have the Java virtual machine that can also be configured. The memory configurations are separate from the operating system. And then you have the operating system. Now when you get all the way to Go, there's just Go in the operating system, pretty much. So you trade off a lot of benefits of using like something that's industry vetted and stuff like that, but it dramatically simplifies the deployment process and management. If there's something going wrong, it's wrong with your code. It's not some like weird configuration file that you're gonna have to Google and like just sort of guess how to fix. It's really simple, especially if you're just standing something up on your own. But yeah, overall, you do run the risk of needing to reinvent the wheel. So for example, I needed to make a proxy server with Go. That's like already built into Apache, but I think I was able to build it faster than I would have been able to figure out how to do it with Apache. So there are trade-offs. Oops. So this is a sort of funny one, a simple one. I think since my time at Next Jump, I've probably spent days or weeks arguing the way that code should look at various points in time. You know, should you use tabs or spaces? Should the opening brace of a function be on the same line or the line after? Should you put a space after a comma? Like all these arguments that are really a waste of time when you think about developer productivity, but it really helps readability. Go comes with a formatter that just sort of solves all that. You're supposed to use the formatter, it sets the spaces, and you don't care about any of that because once you run the code, you run Go format, and it takes care of everything. The benefit of this is you don't have to have these arguments anymore. Everybody's code looks the same. It's not like I choose to put comma first notation and someone else chooses to do comma last. It all will be the same. So that's like, it seems like a small thing, but it's really nice when you're looking at code and you know how it's going to look, and you don't actually need to worry about formatting in every like tab and space. It's all taken care of by the language itself. And it's not, you've seen like there's PHP formatters that you can find on the internet. They don't work, right? It might work, it might actually break your code. There's no guarantee that a formatter will not break your code. But because Go's formatter is part of the language itself, it will not break your code, so it's very safe to use. Overall, like just in summary of why we use Go, it's fast, it's a very fast language, it's simple and easy to learn, and when you look at someone else's code, it's readable. In a large team environment, that is a very critical feature of the language. It's also predictable. You don't have to worry about something going haywire because you couldn't tell what the variables were actually going to do in production. And the last reason is, as Tom mentioned in the bake-off, our developers voted for it. We actually did have that process, if you guys remember, a few years ago where we were pitching and like weighing the options of different languages, and Go came out as the top choice overall. So I didn't want to just sort of sing the praises of Go without talking about some of the trade-offs. So there are contrary opinions on Go, so I'll read off one of these. Go has the potential to become the next C, that is, to hold the computing world back for 4 or more decades to come. I wish it had never come into existence. So this is an internet opinion I was reading in the comments of an update about Go 1.4. And this is not an uncommon point of view because a lot of developers are used to having features like inheritance and like these are basic features. The Go language creators have deliberately chosen to leave those features out, and that's not necessarily a popular opinion. The thing I'll leave you with is Go is not the right tool for every single application that you have. There's going to be cases where you're doing a lot of text manipulation, use Perl. Or if you want to do like a lot of Lisp manipulation, use Lisp or something. There's different options for what you need to do. Go is really good, I believe, because it allows us to work together as a team and effectively edit each other's code and have enterprise code. So I'm going to go very quickly over the Go language because some of you are already working with it. There's various levels, and it's actually pretty simple. So let's get into it right here. So the first concept I want to talk about are packages. Packages are the modules of code that allow you to split functionality across multiple files. The way you work with them is there's a package declaration at the top of every file, and then there's also imports. So I'm saying here I want to use the format package and I want to use the HTML package. Now those packages are now available within my code, and I can use those functionalities like HTML escape string and format.println. It's pretty straightforward and models itself after a lot of other languages. So variables in Go are pretty straightforward as well. There's the same common types that you would see in most languages like C or C++. Boolean, integers, unsigned integers, bytes, floats, and strings. Those are pretty much, and they're usually numbered, so like float 32 versus float 64. They can be declared at the function level or the package level. So for example, first name and last name here are package level declarations, whereas age is a function declaration because it's inside a function, so it's not available outside of that function. Now, the one thing I want to call your attention to is that you'll notice that first name has a capital F and last name has a lowercase l. That actually matters. So visibility outside of the package is determined by the case of the variable itself. So first name is going to be publicly available pretty much, and last name will have a visibility similar to protected. It will only be visible to the functions and code that's in that package. The only other thing I'll mention is this is a very like a long form declaration where I'm saying var age int. You can also declare and initialize a variable all in the same instance with this colon equal sign operator. So this is what that's going to do is it's going to say the city variable is going to be defined and declared based on the whatever's on the right side of this expression. So it's going to be a string because I have a static string there called Cambridge. So functions are pretty much like you'd expect. The one interesting thing is that the function names, the case also matters. So if you have a function that starts with a capital letter, that function is going to be available outside of the package. If it's lowercase, it's only going to be available within that particular package. They can take 0 or more arguments, and they can also return 0 or more arguments, which is interesting. The primary use case that I've seen of returning multiple arguments is you'll have a function that returns the value, and it will also return an error message, and then people will check and see if the error message has anything in it. If it does, then it throws the error. If it doesn't, then it continues on as expected. So that's a very common use case of multiple returns. Flow control, very similar to what you'd expect. There's if, switch, and for. There's no, like I said, there's no do while or while statement. There's only for, and you can do everything you need to with the for loop. The only thing to note is that there are no parentheses. So you see I have for, no parentheses, and then a range expression with some ifs inside of it. There's no semicolons either, but that's pretty much it. Range works as you'd expect. It generates a range over the numbers slice with like setting the values index and value. So there are a few other important types to be aware of. There's more than this, but the most important things are slices, maps, and structs. So a slice is basically an array. Underneath it, there's just arrays happening. But if you're writing Go code, it's actually very simple because it's growable. It's not fixed size like in C. So here I've declared an integer slice, and I can actually add more numbers to it without having to like redeclare a new array or anything like that. Maps work very similar to a dictionary in Python or an object in, I guess, or an associative array in PHP, for example, where you have a key and a value. They're declared like this, where you have the word map, you have the key type, and then you have the value type. So this is a map of integers to strings. You allocate them with make, just like you would pretty much. It's the same function that you use to allocate slices. But the only difference is you can have, it's growable as well, but you can have any type. You could have a map of strings to strings or some kind of object to strings. It's useful in a lot of different scenarios. And then a struct is a very rigid data type similar to an object where it can contain different fields within it, and it's very rigid. So if you have a struct like this person struct that I've declared here with a name and an age, after you've instantiated or allocated memory for that struct, you can't like add a new field to it or anything like that. A person is always a name and an age. You can't like add in a city. It has to be declared as such, otherwise it's not going to work. So I've flown through the basics of Go. There's a lot more to learn that I skipped over, in particular pointers. If you look at our NXJOS, you'll see lots of pointers, so if you don't know how they work, that's going to be tricky, but they're easy to pick up. There's also a lot of interesting concurrency that is possible with Go, and I'd argue that it's actually, it's much easier to do than it is in other languages. There's other data types that are important to know, like Go routines and channels and selections that are all related to concurrency. And Go also has object-oriented like properties, like interfaces and methods and embedded types that allow you to reduce the amount of duplicated code and reuse different functionality. So anyway, I'd encourage you to take a look at tour.go.com, or I don't remember, but it's in the presentation. So take a look at that, and then that's actually how most of I think our team has learned. There's no like great book or anything. All the resources are online, especially because the specification is so simple. So I'm gonna change gears a little bit and actually just go into an example project that I have written using Go and some database functionality. So I watch a lot of movies, and I'm always looking for new ways to find movies or new movies to watch. So over the holidays, I went through and found this source of data called the Greatest Films Poll, which this British Film Institute runs this poll where they ask a lot of critics, academics, and directors what their top 10 movies are, just like of all time. And they compile all this data. There's probably about 1,200 people that they interview, so that's approximately maybe like 10,000 different movies that get selected, not including for overlap. They have that data on their website, but it's not very easily browsable. You can only sort of see it by each voter. So I wanted to say, like, all right, I really like the movie The Thin Red Line. How can I find the critics that like that movie, and then what the other movies that those critics also like? So I built an application in Go that allowed me to do this. And I also combined it with data from IMDb, so I could have the image and the IMDb rating and like all that information that I commonly use when I'm evaluating what movie I want to watch. So in terms of the overall process, I could cover this in a different tutorial or something, but I spidered the BFI site and downloaded all the data that they had. It was powered using Drupal, so it was very structured and it was easy to crawl and like pull out all the necessary data fields. After that, I used the OIMDB API in order to pull IMDb data for each movie. And I pulled all of that into a SQLite database so that I could use Go in order to access it. After I had that done, I started to think on the design. So I was thinking a 3-page design. One, where you'd be able to type in the name of a movie and find it if it's there. On the top right, that's what's there. On the bottom left, it's just like the name of a movie, and on the right is like sort of the movie detail page. So I just sort of architected what I wanted, and then started building. So from there, there's 3 really important libraries you need to be familiar with in Go if you want to build your own web application. The first is net/HTTP, which allows you to build an HTTP server, but also an HTTP client. There's database/SQL, which is pretty much a generic interface for interacting with any type of database that you'd need to, and then you pull in separate implementations depending on if you're using Oracle or SQLite or MySQL or whatever. And lastly, I used HTML/template in order to build the different pages that I showed. So just quickly to cover this, on the left is an example of server code, and on the right is an example of client code. This is the exact code that I used to build the server on the left. That's all the code you need to set up the server. So there are 2 really important things. One is that I'm specifying what happens when someone hits a specific URL. So I'm setting up all the routes. That's what these functions are doing. And then I'm starting the server. That's pretty much all that happens in this file. This is the main entry point of the entire code base. And then there's some client code that I had to write for various reasons in order to get around security policies of IMDb. That's on the right, and that's just basically making REST requests. It's pretty straightforward. You specify a URL, you download it, and it returns a response, and it also returns an error code. If the error code has information in it, I log an error message. If it didn't return an error code, then I spit out the image data into the server. Or into the response, sorry. So the next package I talked about was database SQL, which is used to connect to the database. There's 2 steps here. One is to connect to the database. In the case of SQLite, the database is just a file that's on the server. So you specify the file name, and if you're opening the connection, it returns a database handle and an error message. And if the error message if there is an error message, I'm logging fatal. So log fatal will actually stop the server. What that'll do is, if you can't connect to the database, the server doesn't start. So that's a choice I made. Then, once the database is connected, you can write functionality like this where you're actually querying the database. So very straightforward, similar to what you might see in Empire. I have a query, and then it iterates over the results, fetches the data, and returns it. Lastly, the first 2 things those are functionalities that are pretty much in NXJOS. Like that's, I looked at NXJOS to see how they did it there and then moved it into my system. This is a little different because NXJOS doesn't have front-end code. It's a web service layer. So this is 1 layer higher where I'm actually rendering the HTML view in Go. And it has a really nice templating library built into it that allows you to loop and spit out data that's in the Go infrastructure, or in the Go memory. So it looks like normal HTML, or handlebars, if you're familiar with that, and you can spit out. So this means there's an object that's being applied here that has a property called movie, and the movie struct probably has a property called title, and I'm rendering that into an H1 tag. That's all this is. It's pretty clear, and like the documentation is actually really helpful. And it's also, if there's any issue with the template, it figures it out during compilation, which is also nice. So then there's putting it all together. Let me do a quick demo of what the application looks like. So I deployed it very easily actually on an Amazon VM. So this is one of the nice parts where, because if you remember the slide where I talked about the different stacks like PHP and Apache and Java, JVM and Tomcat, because Go just runs, all I needed to do was compile it on the server and run it. There was no configuration really necessary. I just put it there and ran it, and everything worked as expected. So I'll give the thin red line example. So I have autocomplete. That's just a JavaScript library. I wrote very little front-end code for this. This pulls the thin red line movie details where I'm getting data from IMDb over here. This image is also from IMDb. I can see the critics that voted for this film. So for example, I don't know, this person. And then I can see what other movies they voted for, that particular critic. But if I scroll down, this is where the sort of intelligence comes in. I can see the popular movies among the critics that liked Thin Red Line. So now if I'm trying to pick a movie tonight, I've been meaning to watch Man with a Movie Camera, and people that like Thin Red Line also like that. They also like this movie Rear Window, so maybe I'll watch that. This is the whole sort of point of building the application. So the last thing I want to talk about is I'll just walk you through the way I organize the code. I showed very sort of laser-focused snippets of database and starting the server and also the HTML templates, but I didn't really show how it's all organized. So all this code is on GitHub. So if you want to take a look, or if you want to do a project that's similar to this, you can just clone this or do whatever. There's the overall structure is similar, I think, to Empire or NextJOS. So the entry point for the server is this file moviebrowser.go. That starts the server. And then there's a few important packages. Data is where I use data-SQL /SQL in order to set up the database connection. Gateways are different files that are used to access the database. So gateway is a enterprise design pattern where you have a class that represents a table in your database. So I've created gateways for the movie table and the voter table. Handlers are very similar to controllers in Empire. So each one, I have the home controller for the home page, the movie controller for the movie detail page, and the voter controller for the voter detail page. Objects is very similar to entities within NXJOS. There's no concept of that in Empire as far as I know, where there's rigid data structures for different types of data. So for example, a movie, this is the object that will always represent a movie in my system. It has an ID, a title, a raw title, which is not important, a year, and like a bunch of different other movie-like properties. The same is true for voter. Like I've organized that data into rigid data structures that are common throughout the whole system. Static is this is just sort of a server deployment directory where I have my JavaScript, not HTML, images and CSS, some of the different properties that I used when creating the actual website itself. The last thing are these templates. These are the Go HTML template implementations where there's different loops and things happening. So in this case, this is the voter page where I can see a list of movies. So you have a function called range that will operate over the property called movies, and it will spit out a table row for each one of the movies. Very simple to do, similar to like in PHP where you have a for each loop. The difference is that this language is purely a template language. It's not like a secretly Go or something like that. So it's a little bit safer, I would say, than having PHP rendering your templates. So let me just walk through a few pieces of the code. As I mentioned before, this is the code that starts the server. It specifies all the routes. One thing is, if you were creating a system like this that was more complicated than what I'm doing right here, you may want to consider having a more complicated router. For example, in XJOS, you'll see the router.go and the implementation of the router in the libmux folder. That's a much more robust approach to creating a routing infrastructure. This system, though, it was really basic, so I didn't want to do all that. There's also third-party libraries that allow you to do really complex and sophisticated routing where you have regular expressions that determine which controller executes for a given route. But this was so simple that I really only had 4 routes, so didn't need to do all that. So that file starts the server, and then for each, let me just go back. So when a user goes to the movie directory, the handlers.movie package is executed. So that means it comes here, and when this function executes, it should spit out this line executing the movie handler. So this is movie. This is just the logs for this thing. So if I refresh that a few times, you'll see it spit out the data from the logs that are in the code there. This is just like a nice way to sort of have a sense of what's going on. But for the most part, I'm doing the variable management myself. So the URL has other things. It has an ID in it. I parse that variable out of the URL manually, and then use that to do a lookup in the database of the movie. That returns that movie struct that I showed. And then I end up passing that data to the response using this function sendResponse. SendResponse is a common function that's in this common.go file. Since it is lowercase, it's not available outside of this package, but all of these files are in the same package. That's one thing that can be a little confusing. Packages aren't files, they're actually the folders. So movie.go can access all of the functions that are in common, even if they're not uppercase. So that's something to be aware of. But overall, this is where the templating structure comes in. There's the front-end templating language, and then there's actually the API that you use to render templates. That's where I'm doing all of that logic here in this sendResponse function. There's also a JSON marshalling function, but that's just for the autocomplete list. Besides that, the only things I'll mention are the database code and the gateways. It's very similar, I think, to how Empire works, where you have, in this case, a very simple query like this gets all of the movie information. It loads them into the movie structure, an array of them, and then returns it. And every sort of function is like that. This is a more complicated and ugly query. That's the one that does, for this movie, get all of the critics that like that movie, then get all of the movies that those critics like sorted by the number of votes that they held in common. So I do all that with SQL. Ideally, it would probably not be in SQL, but anyway. That's the overall structure of this program. So I want to leave time for questions overall. I would say if you're interested in learning more, definitely check out the Go website. It's a great resource for learning it. And then this code is also available. This code is also very similar to the way that we've structured the Super Saturday engineering test, which is also written in Go. So I'd be happy to share more insights with you or walk you through any questions that you have. So thanks, and let's open it up to questions, I guess.